In this video, I'm going to go over how to graph a quadratic given vertex form. So right here, we've got f of x equals negative, in parentheses, x plus 5 squared plus 4. This is vertex form, and the reason it's called vertex form is because in this form, it makes it really easy to find the vertex. So we find the vertex here we've got minus h in parentheses, and then plus k outside. Now the reason it's called minus h and plus k is because we always need to remember that h is opposite. So because there's a plus 5 in the equation, we actually have negative 5 as our h value. Now 4 plus 4, that means k is 4. That one stays the same. And that right there is our vertex. H is the x value of the vertex and k is the y. That also gives us the axis of symmetry because the axis of symmetry is at the x value of the vertex. So it's at x equals negative 5. So I'm ready to go ahead and plot this right here. 5, we've got our axis of symmetry, and then the vertex at negative 5, 4. 1, 2, 3, 4. All right, the next thing we want to do is plot some more points so that way we can get the picture of the curve. So I'm going to choose to plug in negative 4 and negative 3, just because those points are right around the vertex, and so that'll give me a good picture for this graph. So I'm going to start with f of negative 4, and that's negative 4 plus 5 squared plus 4. Simplifying this, I get negative 1 squared plus 4. 1 squared is 1, so negative 1 plus 4 equals 3. And so therefore, we get the ordered pair negative 4, 3 as one of our points. The next number I'm going to plug in is negative 3. I'm just picking these because they are going to be around the vertex, okay? If you were to pick, say, positive 1, it would be fine because you can plug 1 in, but the value you get is probably going to be off of our graph. So that's not very helpful when we're trying to graph these equations. So I'm going to plug in this negative 3, so we get negative 3 plus 5 squared plus 4. All right. Negative 3 plus 5 is positive 2 squared plus 4. 2 squared is 4, so negative 4 plus 4, that equals 0. So we get the ordered pair negative 3, 0. This is actually a special point, if you notice where it's sitting. That is on the x-axis. And then, oh, I forgot the other point, negative 4, 3. There we go. All right, so now we found 2 points on the right side of the axis of symmetry, and we want to find the points then on the left side. And we can do that by using the properties of symmetry. So from one of the points, we're going to count from the point to the axis of symmetry. I move 1 space over, and then I repeat that on the other side. 1 space over, and there's my point. I'll do the same thing for this next point. I go 1, 2 spaces over, and so I repeat 1, 2 spaces over, and there's the 5th point. Connect the dots, and we can draw our parabola. All right, now we're going to fill in the characteristics. The first characteristic is the domain. Remember, domain is x values, so that's how the graph moves left and right. We move all the way to the left. This graph goes left forever and ever and ever. And so to the left forever would be negative infinity for the x values. And then it also moves to the right forever. I know it's also going down, but notice we're really just focused on left or right, and it's moving right forever. So the right forever would be positive infinity for the x values. Now range is the y value, so that's up and down. Does it go down forever? Does it go up forever? This graph goes down forever. It goes down, 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 down. On both sides, it's pointing down forever. So down forever for y values would be to negative infinity. And then as we're tracing the graph and going up, 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 ooh, it stops. There is a highest point here, and that highest point is at our vertex. So this graph does not go up forever. It gets stopped at the vertex, which is at +4 on the y-axis. So our range goes up to 4. Now we use a bracket here because that is a point on the graph. So we'll use a bracket for 4. This graph has a maximum point, and that maximum point was the point that showed us the maximum value for our range. It is right here at the vertex. So the max point is the vertex. And if you watched the last video, I mentioned before that this max or min, it can be found at the vertex always, but also we know it's a maximum or a minimum depending on the value of a, which for this problem is right here in front of the parentheses. If in front of the parentheses it's positive, we will have a minimum, but if it's negative, we will have a maximum. So that's a way to tell without even graphing whether we'll have a max or a min. All right, for intervals of increase or decrease, again, this is where we imagine we're riding the roller coaster from left to right. So as this graph starts all the way at -infinity, and it goes up, 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 and then your roller coaster changes and it starts to go down the hill. So our first interval of increase, it starts where the graph starts on x values. So we start at -infinity for the x's. And it continues to increase until we get to the vertex, which is at -5. Again, remember these intervals are in terms of x values. All right, now on the other side of -5, after we stop increasing, we turn and we start to decrease. So that starts again at -5. And then we decrease forever and ever and ever and ever until +infinity. Now you might be a little bit confused here, so let's be clear. Decreasing, it is decreasing because it's pointing down, right? It's moving down as we go left to right. Down is the y values. But our interval is written as x values. So as we're traveling down, we're moving to the right. And remember, right is positive for x values. So that's why the interval of decrease goes to +infinity, because it's moving to the right and x values get larger as we move to the right. All right, now let's talk about the intervals of, let's see if I can, positive and negative. So positive and negative intervals, this refers to being above or below the x-axis. It's talking about whether our y values are positive or negative. So we have positive y values for this portion of the graph, and we have negative y values for these two portions. Again, because the green portion is above the x-axis, and the purple portion is below the x-axis. So it's the x-axis that cuts off our positive and negative intervals. And it's the x-intercepts specifically that help us find where the intervals change from positive to negative. So I'm going to start with the first interval on the left, which is negative. Again, we're going to start writing these intervals in terms of x values, because the positive or negative part, this already tells us what's happening to the y's. So now we need to write our interval as the x's. The interval starts, well, when the graph starts, which for x values, we start at -infinity. And then it's a negative portion of the graph until we get to the x-intercept here at 1, 2, 3, 4, 5, 6, 7, -7. Then on the other side of -7, it starts the positive interval here. So we've got -7, and it stays positive until x gets to -3. Then, on the other side of -3, we become negative again. So we put the u there, -3, until, well, it continues negative forever and ever and ever. But remember, this is moving to the right, so until +infinity. I also want to mention too that you'll notice that all of these intervals, they kind of overlap. The first one goes to negative 7, and then the next one starts at negative 7 and ends at negative 3, and then the next one starts at negative 3. So they always overlap like that. Finally, let's do our x-intercepts. We've got one at negative 7. We always write these as ordered pairs. We have another one at negative 3. Remember, that's where we cross the x-axis. Now our y-intercept, we don't see it on the graph. It doesn't happen to be one of the points that we plotted, so we're going to have to go ahead and plug in to solve. Remember that the y-intercept is found when x equals 0. So I'm simply going to plug into the equation 0 for x and solve for y. So 0 plus 5 squared plus 4. I get negative 5 squared plus 4. Be careful with these parentheses. Make sure that you are doing it in the order of operations order. So we've got negative 25 plus 4, which equals negative 21. So our y-intercept is at 0, negative 21. And the last thing is end behavior. As x approaches negative infinity, this is the left side of the graph. So on the left side of the graph, we are moving left. We are also moving down. So f of x approaches negative infinity. On the right side of the graph, that's as x approaches positive infinity on the right. As we move to the right, our graph is also pointing down. So that means f of x approaches negative infinity. Remember that the end behavior can always be found simply by looking at a. If a is positive, then both of the ends will point up towards positive infinity, and if a is negative, both ends will point down towards negative infinity.